In last lecture, we have been talking about the gas fees in transactions. So the gas you need to pay for when you are making transaction. In this lecture, I'll continue with additional AI lecture, and I will be talking about some additional stuff, especially when you are creating the transactions, why we are also calling the contract here. So why, when we are running truffle migrate, why we are not just deploying contract, but why we are also calling this contract here. All right, let's start, and let me a little bit recapitulate from the previous lecture. I would like to again emphasize here the basic transactions when you are sending money, Ether or from account to account costs 21,000 gas, and a gas has some value. The gas has a value of a Ether. Okay, you need to pay the Ether for a gas, and usually this is stated in a GWAs. So when you go to a Ethereum or Ether gas station, you will see the gas price in a way, and you have these three different prices. You have a fast price, you have an average price, or a slow, right? So so you have a slow, average, and you have a fast. And usually the slow is of course lower. So the slow, for example, can be 20 GWay, average can be 25, and fast can be, let's say, 30. So whatever you will choose. So when I'm making transaction, I will choose the 30 GWay for a gas. So 21,000 multiplied by 30 GWay. I will transfer it into Ether, and that's how much I will pay for a transaction. We saw the transaction here, we paid for 360, but the gas fees were quite high at the time. Okay, so now let's continue with this other thing I was mentioning. Okay, let's open Ganache here, and whenever we are migrating the contract, we are also calling the contract function. Okay, so yeah, as I was mentioning before, we can call the contract functions when they are on the blockchain. This is actually happening automatically for us when we are running truffle migrate. Truffle migrate command is deploying the contract, and also it's calling the contract function. It's calling this function here on the migrations.solve. It's calling the function set completed, and here it will provide the number of the completed migration. Okay, so when we have deployed only migrations.solve, so when only this has been deployed, the contracts, the migrations, you would see here last completed migration would be number 1. When we are deploying the faucet, faucet contract, last completed migration, we will deploy first the contract. The faucet is a faucet contract that is being deployed to the network. And the second call, the second transaction, is going to migrations contract, and it's setting this last completed address basically to the 2. So we know that last completed smart contract that has been deployed or migrated was of our faucet migration. So when I will run here, for example, I will go to faucet here, and I will run here again truffle migrate. This migration contract is keeping track of all of the migrated migrations, and you can see here everything is up to date. Actually, yeah, there is nothing to compile because we already compiled, but network is up to date, so I'm not able to deploy my contracts any longer because my migration contract is keeping a track of all of the contracts, and they are already on the network, so there is no reason to redeploy them to the network. Okay, so that's usually happening automatically when you are using Truffle, when you're running Truffle migrate. That this will also, you will have this migration contract, and whenever you're deploying the other contracts, also set completed function with the number of the migration will be executed, and it will set it to the storage of the contract. So we know what was the last migration we have, what was the last contract we have deployed, number 2. Okay, and we have setting here the number 2 contract we are deploying here to faucet migration. Okay, the other thing here I would like to talk about here is this is the transaction that has been deployed the contract. So that's a transaction that has deployed the contract, and let's take a look here on the transactions. Here is the transaction that deployed contract, but I would like to inspect here. We already know that the transaction data here is a contract code. When we'll take a look on the contract call, we can see here transaction data. The transaction data here is not the contract code, but actually it's a contract code, but this is the signature of function that we should call. Because of course, on the blockchain, as I told you, your contracts are in the format of the bytecode. And here I am saying, this is telling me what function I should have call. This is the hashed version of the function, and this is the number 2. That's this input parameter we are calling here. This 4 bytes here, saying to what function call is sent completed. And this part here, this 2, is the parameter of the function which we are passing this number to. I'll be talking about this in the next lecture in a bigger detail. I would like to first introduce you hashing functions because these transaction data are hashed. Okay, and how they are hashed, I will show you now. So what is the first hash function? In Ethereum network or Ethereum, a very popular function, hashing function is called Keccak256. 256 is saying that the output length of any string that will be hashed will be 256 bytes, which means 32 bytes. Okay, so this function works following. Okay, so I will provide an input, let's say any input, right? It can be binary data, it can be string data, it can be anything, it can be file, and so on. So I can provide some data. Let's say I'll provide my name. Okay, I'll provide my name. I will run it through the Keccak function. So this will run through the Keccak function. And I will get this input in hexadecimal format. Okay, 3201AB. And I will have a 32 of these bytes. So I will have a 32 bytes. 32 bytes. And it's always 32 bytes. Okay, that's what this function does. And it doesn't matter what length of the string I will provide here. It can be longer than 32 bytes. It can be the entire file of strings. It always will output me this 32 bytes hashed version of this string. What is special about this hashed version of this string is very hard to reverse it. Okay, what I mean by that, if I will give you this number I got from the Philip name, so 0x3201AB and so on and so on, if I will give it to you and I will tell you, get me the original value, you don't have any other option just to randomly run the strings through the Keccak function. So you will try, okay, I will try to run there, let's say I will run Philip. I will run the Pete. Oh, Philip, okay, that would be already, he would find the solution, so he doesn't know about it. So first we'll try Peter, we'll try the A, B, we'll try 37, we'll try 100, we'll try to run it through the Keccak function. We'll see what outputs they will get, and we'll try to compare it with this one. But there is no way just to reverse it and to get from this here, get the original value. It's very hard. You just need to randomly run values through Keccak function, basically. So that's a special thing about this Keccak. That's a one-way function. It's very hard to reverse it. And when you see this in a ganache, this is also run through the Keccak function. These input bytes are run through the Keccak function. I will show you how in the next lecture. But first, I would like to show you this. Not this one. Okay, I would like to show you Keccak function. So Keccak256. All right, and here is online. Okay, I'll input here my name, Philip, and that would be version of my name. So 32 bytes, I can verify it. So this is here. We can verify it's 32 bytes. Let's get the length. You can see 64 selected. And 64 selected means that it's 32 bytes because this is 1 byte, this is 1 byte, this is 1 byte, this is 1 byte, this is 1 byte. Okay? Because it is in a hex format, so one character is hex. It's hex letter, 2 hex letters composing of a 1 byte, and if the total is 64, you will divide it by 2. You will get number of bytes. So 32 bytes is definitely here. Okay, so that's it. So that's the value. Okay, and you don't have any other way to find it out. So, for example, if I will change just a little bit this string, I will not write here Philly, but I will write here, let's say, there's a Philly. You will see it's completely different string. So there is no way how to deduct that a Philly and Philly are somehow related. They are completely different results when they are going through this hashing function. Okay, I can provide here any values. Okay, and you can see how this is changing. All right. I will always get different value. All right, so that's what I want to tell you about. To keep in mind this Keccak function. This is a hash function, and it's very important in Ethereum environment because it's used quite heavily. In next we'll continue again AI lecture. I would like to talk about how we called this thing here. All right, guys. So that's gonna be it, and I hope to see you in the next lecture. Cheers.